Hi everyone, got this little video on law of sines ready for you, ready to be made. Um, the law of sines deals with triangles, and let me just kind of draw some nondescript triangle here. I'm going to label the angles with A, B, and C. I'm going to use capital letters to label the angles. And I'm going to label the sides. The side that is opposite angle A, I'm going to use a lowercase a. I want that to correspond that way. The side that's opposite angle B, I want to use a lowercase b. And the side that's opposite angle C is I'm going to use a lowercase c. Now there's a relationship, it's called the law of sines, between the sine of the angle, so the sine of angle A, this ratio over the length of its opposite side, little a, is equal for all three angles and opposite sides, equals the sine of angle B over lowercase b, and that equals the sine of angle C over lowercase c. And you can use any combination of two ratios and make a proportion and be able to solve, and we'll see how we do that in the examples. Also, sometimes you'll see it written the reciprocal of all these, where they put the length of the side on top and the sine of the angle on the bottom. It doesn't matter. They work both the same way. Alright, in this video, I'm going to concentrate on if we have two angles and a side given. And we'll try to designate what we have there as we move along. And that's all we're going to concentrate on in this video. So, we are just going to be solving triangles. And what it means to solve triangles is to find the other missing parts. We have two angles given and a side. So let's just try to draw this first. I usually put angle A down here. Okay, I'm going to just draw this out a little bit, an obtuse angle. That's probably a little more than what it should be, but 102.4 degrees. And I'm going to put this at A, and usually I'll put C over here. And I'm going to put B over here somewhere. And label 102.4 degrees here. For little a, I'm going to put 21.6 here. Angle C, let me write it over here, 16.7 degrees goes right in there. And that's all the information we have. What we need to find is angle B. We need to find the length of, this is opposite angle B, so this is little b here. And we need to find little c here. Okay, so that's what we're off to do. So the first thing I would do is I would start with the angle and opposite side that we know. And I would write, that's the sine of A, which is the sine of 102.4 degrees over 21.6 equals, and since I have this angle C hit ready there, I'm going to go sine of 16.7 degrees over the length of C. Alright, so, the cross products are equal, so sine times 102. Well, I'm going to put C times the sine of 102.4 degrees equals 21.6 times the sine of 16.7 degrees. Just solving for C, and you would get that by dividing both sides by the sine of 102.4 degrees. And I'll divide this side by the sine of 102.4 degrees. Now, I'm going to divide that out, and that gives me 21.6. Be sure you're in not radian. Be sure you're in degree mode when we're solving triangles. 21.6 times the sine. Okay. Let me get out of here. Times the sine of 16.7 divided by the sine of 102.4. Alright, I'm looking at C being approximately, I'm going to round, and let's make this a rule of thumb. Let's round everything to 2 decimal places. So C is, I'm going to write 6.36. Perhaps that's a little light. So, okay, so C is 6.36. And the next thing I'm going to go after is angle B. Well, angle B is pretty easy to get because the 3 angles in a triangle add up to 180 degrees. So I'm just going to take 180 degrees minus 102.4 degrees minus 16.7 degrees. 180 minus 102.4 minus 16.7 equals 60.9. Okay, so let's put 60.9 degrees in right there. And all that's left is the length of B. And I'm going to use that angle now. Its opposite angle is sine of 60.9 degrees over B equals, I think I'll use this one since we had those from the beginning. Doesn't matter though. You can use sine of C over C if you want, but I'm going to go sine of A over A. So sine of 102.4 degrees over 21.6. And 21.6 times the sine of 60.9 degrees equals B times the sine of 102.4 degrees. And just keep solving for B. Pretty sure we're going to have to round there. So 21.6 times the sine of 60.9, close those parentheses, and then divide by the sine of 102.4, getting 19.32. B is approximately 19.32. Okay. And if we had units, we'd put them on there, but that wasn't given to us. So, all right. So these are the 3 things that we found. We were given 3 pieces of information. There's 6. There's 3 angles. There's 3 sides. And we found the other 3 using law of sines and the fact that the 3 angles in a triangle add up to 180 degrees. Oh, by the way, let's look at what we were given. We were given this angle, we were given this angle, and we were given this side. That is angle, angle, side. The side is not the included side between the 2 angles. So this is an AAS scenario. All right, let's look at example 2. We got A is 55 degrees, B is 42 degrees, and C is 3/4. All right, so I'm going, let's put A here. I'm going to draw, and I'll put B here. 55, there's 90. I'm going to go, I'll go a little more than that. Right there. 42 is a little more of a angle there. So this I'm marking as 55 degrees. This I'm marking as 42 degrees. This is point C. And the length of this side is 3/4. I'm going to use 0.75 in our calculations. And so we got to find this side, and this angle. So I'm going to go for the angle. I really got to go for the angle first. I got to go for angle C. Is 180 degrees minus 55 degrees minus 42 degrees. All right, so what do we got? We got 180 minus 55. That is 135 minus 42. I think we got a 93-degree angle here. 93 plus 42 is 135. 93 plus 55 is 148. Okay. Perhaps that is 83 degrees there. Okay. Yeah, that looks, I feel a little better about this now. Okay. So that's an 83-degree angle. Probably should have used a calculator, huh? All right. Now, the sine of 83 degrees over 0.75. That's sine of C over C. Got an opposite. And I'm going to do A first here. Put a little b here. I'm going to go sine of 55 degrees over little a. So, let's come over here. A times the sine of 83 degrees is equal to 0.75 times the sine of 55 degrees. Let's divide through by the sine of 83 degrees. A is approximately, I'm going to stay with the two, around the 2 decimal places rule here. Clear this. I'm going to take 0.75 times the sine of 55 and divide that by the sine of 83. And I get 0.62. A is approximately 0.62. That in red, 83 degrees there. And now I just have to find B. I'll stay with, let's see, B. I'll stay with the sine of 83 degrees over 0.75. I don't have to, I just have it there, it's handy. And I will go the sine of 42 degrees over B. And let's keep solving this. B times the sine of 83 degrees is equal to 0.75 times the sine of 42 degrees. And let's divide through by the sine of 83 degrees on both sides. So I'm going to take I'm going to change this 55 to a 42. Oops. That saves me from having to retype that whole thing. And I get 0.505, so B is approximately 0.51. And that has the triangle solved, 0.51 there. Okay. Now I'm done with the two examples. That you see, it takes a while to solve the complete triangle. And all I want you to do, example 3. You've got, this is angle A, this is angle C, this is the side opposite angle C. This is little c. It's 2.68 units long. And example 4 here, you got angle A, angle B, and you've got little c. And then identify, is it an angle side or an angle side angle? All right, so go ahead and get those answers. I am going to show you what I think the answers are to those, but I want you to do the work and just have your work for those and see if you can get it to match up to these. I believe those are correct. All right, you guys enjoy your weekend.